In this video, we're going to look at showing that two lines are perpendicular to each other. So this question says line P has equation 5y minus 2x equals 13. The other line is line Q, which has equation 2y plus 5x equals 7. Then the question states, is line P perpendicular to line Q? So what I'm going to do here is to divide my page into two, meaning I've got line P over here and line Q on this side of the page. So the first thing to notice is for line P, the equation is not quite in the right format that we need. So what I'm going to do is rearrange this equation in the form y equals mx plus c by adding 2x on both sides of the equation. So we'll end up with 5y equals to 2x plus 13. Then we don't want 5y, we need y. So we divide everything by 5. And what will happen now is we will get the following. So we end up with y equals to 2/5 of x plus 13 over 5. So now that we've got that in the correct format, we can do the same for the other equation. Now the other equation we've got, so I'm going to write that down, is for line Q is 2y plus 5x equals to 7. So now I'm going to minus 5x on both sides of the equation. Then I get 2y equals to 7 minus 5x. Divide everything by 2, like so. And then we end up with y equals to 7 over 2 minus 5 over 2x. But we want it in the form of y equals mx plus c. So I'm just going to rewrite it as y equals to minus 5 over 2x plus 7 over 2. So now that we've got that, I'm going to say, right, so I'm going to choose line P and say, well, the original gradient is 2 over 5. So let's label that as the original gradient. And then we said that if you've got a perpendicular line, m nu is always minus 1 divided by your original gradient. So minus 1 divided by our original gradient is here. That's our formula. So we can now apply what our original gradient is, which is 2/5, and we're going to get minus 1 divided by 2/5. Don't forget basic fractions here. So it's minus 1 divided by 2/5. So you could write this as minus 1 over 1 divided by 2/5, which is the same thing as minus 1 divided by 1 times 5 over 2. Minus 1 times 5 is minus 5, and 1 times 2 is 2. Now minus 5 over 2 is exactly the gradient of line Q. So we can say, yes, line. So we can now state line P is perpendicular to line Q. Is perpendicular to line Q. And that's it, we're done. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we can do the same thing as before. Call this line P on this side. Then we've got line Q on the other side. Then what we're going to do is write 7y equals to 3x minus 4. So we want it in the form y equals mx plus c. So we're going to divide everything by 7 here. And what we end up with is we get y equals to 3 over 7 x minus 4 over 7 as our equation. So now that we've got that in the correct format, we can do the same for line Q. So line Q is 3y equals to 5 minus 7x. This is not in the correct format, so let's divide everything by 3 first of all. So in red pen, so we get divide by 3, divide by 3, divide by 3. Now what we get here is y equals to 5 over 3 minus 7x over 3, but again we want it to look like y equals mx plus c, so we're going to write it in that manner. So we get y equals to minus 7x over 3 plus 5 over 3. Now we've got the equations in the correct format for line P and line Q. So what I'm going to do is call this my original gradient. So 3 over 7 is my original gradient here. And then what's going to happen is we're going to write down the formula for m nu, which is the gradient of the perpendicular line, as we know, is minus 1 divided by our original gradient. So we write that down so it's clearly in front of us. And then we can say, right, that's basically minus 1 over 3 over 7. Now we know how to divide fractions, so it's minus 1 divided by 3 over 7. So what we're going to do is apply the basic rules of dividing fractions here. So we're going to get minus 1 over 1 divided by 3 over 7. This gives me minus 1 over 1, changes to a times, turn the fraction upside down, 7 over 3, and this will give me minus 7 over 3. And this is exactly the gradient of line Q. So we can say both lines are perpendicular. So we can say, therefore, yes, line P is perpendicular to line Q, is perpendicular to line Q.